The biggest problem regarding accidents is the fact that they tend to occur unexpectedly, disharmonizing the standard environment and often eliminating the surrounding infrastructure. The intervention of the rescue forces is therefore always very complicated, requiring a conscientious preparation to uncover further actual risks and to provide protection for the rescue team itself.
And the hose, at the end of the hose, there is a nozzle. And this is, do we have a picture of this nozzle? Das Gasleck finden. Das zweite ist die Gasart erkennen, die Gaskonzentration messen. Das zweite Ziel. Das dritte Ziel ist die Gaskonzentration durch Wasser verringern und dann nochmals die Gaskonzentration messen.
The situation at an accident gets more complicated if it is caused by chemical substances, flammables or explosives, or if they leak. These types of accidents mostly occur at digging site avalanches, traffic accidents in tunnels, accidents with cistern trucks, on roads or railroads, at explosions or fires in chemical factories, chemical waste stores or in laboratories. Each rescue operation requires pinpoint planning, which is crucial in identifying risks by an analysis of the chemicals at the site of the accident. As a matter of fact, there are just 3 ways how to ascertain it: getting information from the traffic documentation or from the archives, sending out a scouting team, or sending out a team of robots equipped with detectors. The least risky method for a human is to send out robots. In a research laboratory based in Vienna, a team of young researchers invented and prepared a special robot to primarily detect risky substances at digging mine accidents.
Also mein Name ist Matthias Piegel von der Firma Taurop. Wir entwickeln Roboter für Feuerwehren und andere Einsatzkräfte, die sich im Zuge ihrer Arbeit in gefährliche Situationen begeben.
Mein Name ist Lukas Silberbauer. Gemeinsam mit meinen Kollegen haben wir diesen Feuerwehrroboter entwickelt. Der dient in erster Linie dazu, Aufklärungsinformationen zu erhalten. Das heißt, wo die Situation zu gefährlich ist, einen Mann reinzuschicken, kommt der Roboter und teilt dann der Einsatzleitung mit, was in dieser gefährlichen Situation genau los ist.
A little but robust body of the robot contains a fueling unit, a processing unit and an external power source. The self-movable arm carries various gas detectors and cameras for scanning risky places. Before the actual sending out of the robot to aid the rescue team, it is an imperative to undertake technological tests, as well as a test for users of the robot. For this purpose, a specific testing platform has been explored, that is a test bed, where potential robot users meet to uncover 2 new parameters of the new technology: perceived usefulness, the user value of the robot unit. perceived ease of use, the difficulty of handling and the user comfort at handling of the rubber unit. These two parameters are the two most important objects of the qualitative marketing research in technological or product innovations. The preparation of the testing platform is a basis for the qualitative marketing research on the B2B market. Conditions must be in place for the application of the technology, as well as for getting the numbers for a real group of future users. An international marketing research team prepares a complete methodology of testing and a form to make a structured interview with potential users. The body of the robot also contains cameras to enhance its navigability, provided by a radio remote control. For the testing of the robot to identify risky substances at accidents, the international research team suggested and prepared a number of options for robot application, apart from digging mine accidents. This time it is a simulation of an accident when transporting cisterns with chemicals. In the designated area of the Slovak Railway Company, there is a simulation involving a wagon with a cistern, test gas and rescue team. To make the qualitative research of the future users fully objective, representatives of 6 rescue forces from all over Slovakia need to meet. Following the instructions, a full test takes place. The first robot detects the damaged area of the wagon, as well as the source of the leaking gas afterwards. Immediately after evaluating the situation, the rescue team prepares the sending out of the rescue forces from a safe distance. The next robot with a branch pipe and a group of rescuers eliminate the area of gas leakage. Continuously and even after the conclusion of the full test, other attendants try to drive and control the robot as well, and they try to evaluate its parameters. What needs to be evaluated is the reaction time of the robot as well as other parameters needed to evaluate the robotics part of the technology. All outputs of the research are carefully noted in a written and an audiovisual form to be able to return to the user's feedback at any time. Some outputs of the testing need to be run again to verify them. Thus, the research team meets the rescuers again to make the necessary confirmation. In the same way, conclusions for the research team are prepared for the research team to be able to amend and supplement all qualitative parameters. Further technical equipment for broader use of the robot, according to the needs of the rescue teams, for example, a carriage slot for a branch pipe or more detectors. The tested way of using the robot was satisfactory, and its simplicity and user comfort have been confirmed. In the end, a test and a survey have been elaborated when drafting the business model. Now, the robot is ready for full area-wide application by firefighters in Slovakia.